Hey guys, we're going to do the very last section of chapter 10. It's called binomial distribution. And if you have learned about prefixes in English, you know that bi means two. So binomial distribution is going to mean that you only have two outcomes. And so when you meet these conditions, can't write, you can use this process for learning. So there's n independent trials. That's like how many times, or like how many things you have, how many times you're doing this thing. Each trial has only two possible outcomes, success or failure. Means that it happens or it doesn't. No in between. So it's raining or it's not raining. Probability of success is P. Probability of failure is 1 minus P. I sometimes call it Q. Let me show you what I mean. Like, let's pretend that there is a 25% chance of sunshine. So 0.25. That would be P. Then Q is 1 minus 0.25, meaning the rest, like when we talked about complements. So that's 0.75, that it's not sunny. Or if you said, hey, there's a 25% chance that it's going to rain. And you're saying, oh, yeah, there's a 25% chance of rain. Well, then there would be a 75% chance that it's not going to rain. And so they are opposites, like either the thing happens or it doesn't happen. And the sum of those two probabilities has to add up to 1 because it's all the options that there are. It's only two possible outcomes. So when you're tossing a coin, the probability of getting heads is a half or 0.5. So the probability of not getting heads is also 0.5, meaning you're going to get tails because the 2.5s add up to 1. So the way you set these up is you say, okay, N, C, R. This is how many times like you have a certain number of trials or things that you have total. This is the number of times that whatever it is, this is the number of times that it is going to happen. And Dolly's going to take a loud drink because why not? And then you're going to put in here the probability of that thing happening. And that is going to be to the R power, because that's how many times it happens. And then the number of times that it doesn't happen. So this is that it's happening, or this is that it's not. That's going to happen the rest of the times. So if N is your total and it happened R times, then it's N minus R. So even though this makes perfectly good sense to me, she is still drinking and she's so loud. I swear they never drink this much until I make a math video. Let's try to do this so that you're not as confused. It's always tricky when it's concept. Let's do it with actual math. Dolly! Hey, Dolly, I'm making a math video. You have to stop drinking so much. All right. Calculate the probability of randomly guessing the given number of correct answers on a 30-question test. So that's the total. That's going to be N. The exam has A, B, C, or D. So it has 4 options. So the probability of getting it correct is going to be 1/4 or 0.25, which means Q, the probability of getting it not correct, otherwise known as incorrect or wrong, is going to be 3/4 of the time, so 0.75. And they have to add up to 1. So because I have 30 questions, it's going to be 30 choose. Here they're saying you get absolutely none right. So 0 right. The probability of getting them right is 1/4, but that's happening 0 times. The probability of not getting it right is 0.75, and that's happening the other 30 times. Put that into my calculator. I get 1.785, and then I get that E, so it's 10 to the negative 4 power, which would mean take this, move it over 1, 2, 3, 4 to the left. So you get like 0.0001785. So the probability that's pretty slim. I don't care if you want to write your answer like this. Here, I'm going to have 30 tries, but I'm going to get 6 of them right this time. We're going on a little journey now to let my dog out. Hang on, Dolly. We're coming. And so I'm going to take 0.25, which is the probability of getting it right. And I want that to happen 6 times. And then now we're in my basement, letting my dog out. So I'm really far away from my calculator. Then the rest of the time, I'm going to get it wrong. And the probability of getting it wrong is 0.75. If I get it right 6 times, that means 24, the other 24 times, because there's 30 total, I'm going to get it wrong. So what's happening is that each of these is showing you the probability and how many times that thing's happening. So like the probability of getting it right, and that's happening 6 times. This is the probability of getting it wrong, and that's happening 24 times. Now I'm back upstairs trying to get to my calculator, and I'm getting 0.14546-ish. What if you're trying to get half of them right? 15. So of the 30, you're getting 15 right. Probability of getting them right is 1/4. Happens 15 times. Probability of getting it wrong, 0.75. That happens the other 15 times. Probability of that, 0.00193. So definitely less likely than the one before because it's a smaller probability. And last, I feel like this answer is going to be real small because you're totally guessing. So out of the 30, you're trying to get 26 right by guessing. When you only have a 25% chance of guessing right, and you want that to happen 26 times, that means you would only guess wrong 4 times. So these bottom numbers, these probabilities, always have to total 1. And these 2 numbers always have to total that. So because all these examples had 30 questions, they always had to total 30. When I do this on my calculator, I get 1.925 times 10 to the negative 12 because I get that E negative 12. Keep in mind that means I would have to move this over that way 12 spots. So I'd end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros, and then the 1925. So that's not going to happen. That's very unlikely. The probability is super duper low that I would randomly guess 26 right out of 30. But that is the setup for how we do these. What's your total? How many times is it happening? What's the probability of it happening? R times. What's the probability of it not happening? The rest of the times. And that, my friends, is binomial probability. Hope that helps. Bye.